All right, this is Kinesiology 231, an extension of the conversation regarding cardiovascular endurance testing. Specifically, this would be the Astrand-Rhyming cycle ergometer test. Now, with this test, very much it's completed on a Monarch bike or another bike that actually offers tension in a graduated fashion. But many times you'll see this bike used for both tests, the YMCA as well as the Astrand-Rhyming. And with this, now this test itself is a little different animal than the one we talked about previously because of the YMCA and the stair-step approach and how you take a person through that test and incrementally change the resistance as you go. With this test, it's a single stage test and it's only 6 minutes long. It has the same cadence though, 50 revolutions per minute, and generally you'll use a metronome or a metronome on your phone to help set that pace. And the work rates themselves are just based upon the person's sex of birth and also their current fitness levels, which is a little bit murky when you get into this. So when you look at this, the book recommends a more conservative approach when prescribing or implementing in the workloads for the person. But what you'll find is for males, it's either unconditioned or conditioned, and females, it's either unconditioned or conditioned. And you have to kind of take a judgment in terms of if the person's conditioned or not. And from there, you go ahead and choose your workload. So it could be 300 to 600 or 600 to 900 for males, or 3 to 450 for females, or 450 to 600 for females if they're in good shape or good condition. And how this progresses is the person starts on the test, they start their workload, excuse me, and as they go through the test, you take their heart rate after 2 minutes. And with that measurement, it becomes kind of binary. They're either over 120 beats per minute or they're not. And if they're over, then you continue at the same work rate for the 6 minute duration of the test. But if they're under the 120, then you go to the next highest increment until the heart rate is above 120 beats per minute. And then after 2 minutes of riding a consistent work rate or workload. So it's a little bit different, like I mentioned, than the other tests. Now, sometimes you look at this and you can make your determination which test you want to use based upon your person. And this is kind of up to you as a practitioner to choose which test you would like to use, which one you think is better than the other. But either way, you take your data points and you have your heart rate at the end of minute 5, at the end of minute 6, you average those out. You go to table 11.15 or 11.16 depending, and you do an age correction based upon their age. And you'll see this here in a second. So if we look at these tables, right, you have 11.15 right here, and you look at the workload the person's at, and when they get done with the test, the average of their heart rate, and with the average of their heart rate, if say they were average heart rate, 133, they would fall right into this strata right here. And so, you have to be able to navigate these charts as you go through and evaluate what your client actually accomplished. So in this case, 133, they were at the 900 to right here. Let me get in here, 133. You have 3.9. Okay, got it. So you have to jot that down. You take yourself over here. Excuse me. This would be for women. The first one was for males. So if this one's the same thing, they're at 133, and they're at 900 and 150. Okay, so you got 3.3. Okay, got it. Then you got to go to the next one. And depending on the person's age, you'll take that number you just received, and if the person is 37 years old, you're going to multiply by a coefficient of 0.85. If the person's 27, you're going to multiply by a coefficient of 0.98. If they're 25, you're not going to really change at all. It's 1.0, so it's the same. So you have to be able to navigate a couple of different variables in here to be able to do your equations. So now we go ahead and we take this. We go, all right, so we have our prediction, we have our person, we have how old they are, we have their heart rate. Okay, we can take this a step further for this in terms of a female. Same thing, and then we go ahead and multiply it out like we just had. So if we break out those 3 charts like we just saw, in essence what you'll have is a reading for the male population, a reading for the female population, and then you have to then use a coefficient here noted as CF as it corresponds to age, based on the person's age. So again, it's a multi-step process to do this. So if we look at this setup, here we have a 57-year-old female client who weighs 145 pounds, that's irrelevant, and they just completed the test. And here are your data points. Okay, so we know after the second minute they were over 122, or they were over 120 because they're at 122 beats per minute, so they end up staying at the same workload straight through, followed the protocol. And then after the fifth minute, 129, after the sixth minute, 135, we take those two and divide it by 2, it gives us an average of 132. So when you do this, you take your 132, you take your 132 and plug and chug it into the chart. Now if I can go back a screen here, and we have 132, and you go on the chart, let's see what we got here. For our female, 132 at 57 years old. All right, so she got 132, okay, 132, 2.7, cool, got it. So we got 2.7 there, and she's 57. So you know you're going to multiply your coefficient by 0.7. All right, so let's go ahead and take this a step further. We get through it. Okay, so we already found that she was at a work rate of 600 kilogram per meter per minute. That's 2.7 as we saw. Age correlation factor 57 is 0.7 for the correlation. Okay, got it as well. So we take the 2.7 times 0.7, and that gives us an age correction factor of 1.89 liters per minute. Now, if we go ahead and map that out and go into the kilogram number as above, what you find is it comes out to 28.64 milliliters per kilogram per minute. So, you know, the actual weight itself of the person doesn't really come into play until the equation. It doesn't matter in terms of like workload or anything like that, as I mentioned earlier, where it's kind of irrelevant in the front part, but on the back end it's important because you need that number to be able to calculate out the, per kilogram of body weight. So now when you go to the table on 11.18 or 11.18, you end up reading through her 57-year-old. She's good. Okay, this is great. So again, with an Astrand-Rhyming cycle test, and some of these tests, you know, it becomes the labor-intensive side is not so much the test itself, but it's all the calculations you have to do to be able to evaluate the test. What's nice is for some of the field tests, it ends up being a little bit simpler process, and you don't have to worry about doing the mental gymnastics to get through all these different calculations. So now if we look at this, this was an article I threw in here for you guys. I think it's a good one. It compares these two tests, and it's a review of literature. So it's not a study per se, but they review different literature about the tests themselves. There won't be any questions or anything in the class regarding this. It's a 22-page article, but I found it to be pretty informative and good, so I thought I'd throw it in here for you guys. Just do a control click to get out to it. So to that end, guys, you know, as a practitioner, as I mentioned, you have to make the determination on what kind of tests you'd like to do, or you might be in an environment where you have to do certain tests. So as you become more familiar with these, the mental gymnastics and the algebra involved with trying to calculate out some of these workloads, and then also understanding a current level of fitness for a person, will become clearer and clearer, and perhaps you'll start to create your own spreadsheets and be able to just plug and chug and put calculations in, and it won't be that big of a deal. But I will tell you, the hardest part of the test, the physical test, is the onus falls on the participant. The hardest part of calculating out everything falls on the practitioner. So just keep that in mind when you go ahead and administer these tests. All right, guys? Thank you so much.